Good morning. So in this video, I'm going to talk more about sine and cosine graphs, and we aren't going to cover the section quite like the book has it laid out, but by the time I'm going through these sections, we will have covered everything the book did. So we were talking about y equals a sine of bx minus c plus d. And we were just slowly learning what the things did. We learned that A was the amplitude, which determined how high up and how low the graph went. And we learned that D was the vertical shift. And the vertical shift gave us a new midline. So now we're going to learn about what B does. B affects the period of the graph. So you should write that down. So instead of us looking from just 0 to 2 pi, and we would have a period of 2 pi to get that complete sine curve, one repetition of the sine curve. Now we're going to do a little equation, and it's going to be period is 2 pi over b. So far, all the graphs that we have done have been like y equals sine x plus 3, and b existed, but it was a 1, and 2 pi divided by 1 didn't affect the period any, it was just 2 pi. Well, now we're going to get some numbers for coefficients of x other than 1. So we're trying to step this one step at a time and to get used to what each step does. So let's say we have the sine of pi x. Amplitude's 1. There is no vertical shift, but this time we have a b of pi. That means the period is going to change. So the formula for the period is 2 pi over b. So we'll do 2 pi over pi, which is 2, because the pi's cancel. Now we need to get the scale on the x-axis, because it is important that we get those 5 points to use to graph our sine function. And what you can always do to figure out what to count by is you could do the period divided by 4. So for us, we have a period of 2 divided by 4, so we get a half. So we're going to count by halves. So let's go ahead and grow the graph. So instead of me stretching this x-axis out and going from 0 to 2 pi, we go from 0 to 2 with a 1 in the middle. And, well, we can count by halves. So we have 0, and then we have a half, and another half puts us at 1, another half puts us at 1.5, and another half puts us at 2. The amplitude is still 1. Sine starts at the midline, goes up, crosses the midline, goes down, and finishes at the midline. So every point that we label on the x-axis has a different value for sine. Helps us to create our graph. Let's see another one. Let's say we have y equals the cosine of 4x, and let's not do anything else. Well, let's give it an amplitude. So we have an amplitude of 2, and we have a number b that's going to affect the period. So to see how it changes, we'll do period is 2 pi over b, 2 pi over 4, or pi over 2. This graph, it was probably a little bit difficult to tell how much this period changed our graph. But if you think about pi being 3.14, and normally sine without any shifts goes all the way from 0 to 2 pi to complete the curve. And so normally by pi, we're only halfway done. See, we have stretched or condensed this little piece of the graph to just between 0 and 1. So it's a big change. It's not as obvious that it's a big change when we just graph one period. But if we look at it from 0 to 2 pi, it's a big change. Okay, now we have a period of pi over 2. So let's look back at this. Whoops. I guess I have one sketched. So normally when we stretch out the x-axis from 0 to 2 pi, and we have this little spot 2, then it starts here and it just is hitting its height right here. Well, now with this period of pi over 2, it's going to have the complete curve happen between 0 and pi over 2. So it is a big, big change to the graph. And what do we count by? We are going to figure out what to count by doing the period divided by 4. So pi over 2 divided by 4. Make 4 a fraction and flip it up here and multiply by its reciprocal. Because you know we keep change flip. So instead of divided by 4, we multiply by a 4th. So we're going to count by pi over 8s. Have an amplitude of 2 this time. And we're going to count by pi over 8. So we have 1 pi over 8. Well, we could go ahead and get all of our marks. The full length, the half length, and the half and the half. So 1 pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8, and 4 pi over 8, which is pi over 2. So then we just graph our cosine function. Whoops, this is cosine. So cosine starts high, crosses the midline, low point, midline, and finishes high. There we go. The last thing I want to talk to you about is what happens if you have a negative in front of your graph. The first thing you see when you read this graph is that negative right there. So I want you to think immediately that that is a reflection over the x-axis. A is 1, B is 1, and we have a D value of 3. So the period is not affected. We do have a new midline, so we need to fix that. At 3. We're going to go 1 above it then for our amplitude and 1 below it. And period was still 2 pi, pi over 2, and 3 pi over 2. And we have a sine function. Normally, sine starts at the midline and goes up. Well, now that we have a reflection over the x-axis, sine is going to start at the midline and go down. Cross the midline, high point, cross the midline. So it's a complete reflection. The whole graph just flipped. Okay, that's it for today.